So let's look at an example where we can perform our test for independence. In this example, a pharmaceutical company claims that they have created two different pills that help with the flu. Adult Americans are randomly assigned to three different groups. One group takes pill 1, one group takes pill 2, and another group takes a placebo or sugar pill. It was then observed whether or not each person got the flu or not. And so these are the results of the experiment, and we can kind of see that with pill 1 we got 20 that got the flu and 100 that didn't get the flu. With pill 2 we got 30 that got the flu and 110 that didn't. And then with the placebo we got 30 that got the flu and 90 that didn't. Okay, now before we start to think about the independence between these two events, in other words, if one event being which pill they got, whether they got pill 1, pill 2, or a placebo, and the other event whether or not they get the flu. So we want to see, are these two events independent? And if there is some dependency, that might tell us that one of these pills is actually effective. Otherwise, if there's no, if these are all independent, then it would seem that whichever pill we choose wouldn't have an effect on whether or not we get the flu. So before we do that, let's total up all the rows and columns. So we'll go ahead and add up each of these columns here. So 120 in the first column, 140 in the second column, 120 in the third column, and then I'll also add up each of the rows here. 20 and 30 and 30 gives me 80. 100, 110, and 90 gives me 300. And then the grand total here should be 380. Double check to make sure these add to 380, and then also here these also add to 380. Okay. Now with those totals, let's try and think about the probability of some of these events occurring. For instance here, what is the probability of choosing a person who has the flu? So if I'm picking one of these 380 people at random, well, we have 80 of them that had the flu. So we have the probability that somebody has the flu is 80 over 380. And one thing that might help here would be to think of this as a decimal. So 80 over 380 is about 0.21. What's the probability of choosing a person who does not have the flu? So the probability that they don't have the flu, well, we've got 300 people in total that don't have the flu out of 380 altogether. And so what would that be roughly here? So 300 divided by 380 is roughly 0.79. Now, of the people who took pill 1, how many would you expect to have the flu? Okay, so what they're asking us here is, what should the expected value here be in this entry here? Well, we got 20 that we observed, but if events A and B are independent, how many would we expect to have the flu? So what we can do is think about our expected value when we're computing the expected value. We would take the row total, which was 80, times the column total, which was 120, and then divide by the grand total, which was 380. And that should tell us roughly what we would expect to see if these two events are independent. So if I do 80 times 120 divided by 380, that's something about 25.26. And then of the people who took pill 1, how many would you expect to not have the flu? So here again, I can add up the totals. Well, we actually already added up the totals. So if I'm computing now the expected value for that entry there, what I'll do is I'll multiply the row and the column total there. We have in the column 120 and then in the row 300. So we'll do 300 by 120 divided by the grand total, which is 380. So when we multiply these guys and then divide by 380, we get an expected value of about 94.73. Okay. And comparing them, so here the expected value for this one was really 94.73. The expected value for this one was really 25.26. But it appears that here the number of people that got the flu was actually less than what we expected. So maybe that tells us that the pill really is somewhat effective. And now looking at this next part here, let's do that for each entry in the tables. So we've already did it for these two entries here. We got 25.26 here. We got 94.74 here. So let's do that here for pill 2 now. If I remember here, we had 140 as the row, and then we had 80 and 300 here. So let me just fill these back in. So the expected value for pill 2, the expected number of people that we would expect to get the flu if the choice of pill is independent of whether or not we get the flu, let's see, would be 30. So we're going to take the total, which was 140, times the total here, which was 80, over the grand total, 380. Okay, 140 times 80 divided by 380 gives me, let's see, about 29.47. And then let's do the expected value for those who took pill 2 and didn't get the flu. So here we would do again the total in the column, which was 140, times the total in the row, which was 300, divided by the grand total, 380. So when we compute that, we get something around 110.52. And actually what I notice here is that the expected values that we get for pill 2 are actually a lot closer to the observed values than what we got here. So maybe pill 2 is actually not as effective as pill 1, because here we get something where the observed values of those who got the flu compared with the expected values pretty close. So they're not too different. Now let's do the placebo. What would we expect for each of these? So for this one, we've got 80 in the row, 120 in the column. gives me an expected value of about 25.26. Actually, notice it's going to work out to be what we got here. And then let's see, for this one, we'll get something similar to what we got over here, because again, we're doing the total in the column was 120 times the total in the row, which was 300 over 380. And we get essentially exactly what we got back here, because those are the same totals. So 94.74. Okay, so when I compare these values now, for instance, when I look at the expected values of pill 1 compared with the observed values of pill 1, it appears that pill 1 may have an effect in reducing the number of people that have the flu, whereas pill 2, the observed values are pretty close to what we would expect if it didn't have an effect. The same here, we've got something maybe not as close, but the placebo actually doesn't appear to be too far off from the expected value, but actually here a little bit in the other direction than it was here for pill 1. So now that we have all the expected values, let's see how we can perform the hypothesis test. So remember, for the null hypothesis and the alternative hypothesis, it'll always be the same thing. So for the null hypothesis, it's that the choice of pill is independent of whether or not we get the flu. And then for the alternative, is that they are actually dependent. So to the choice of pill here, and whether or not we get the flu are dependent, meaning that there is some relationship between that. In other words, maybe the pill has an effect on whether or not we get the flu. For the test statistic, chi-squared value, remember we're summing up all the observed minus expected values, and then squaring their differences, and then dividing by the expected value. So in this case, well, we've got 6 entries here, so we'll need to sum up 6 terms. So we can go through each of those values, right? So let me remind myself what we got for each of these. So here we had the observed value was 20 for the pill 1, minus 25.26 was the expected value. So that's for the first term. So let's go along the first row here. So the next one would be 30 minus the expected value that we got there was 29.47. And then moving on to the last row there, we had 30 was the observed value minus the expected value was 25.26. And then for the next one, it was, so moving on to the next row here for pill 1, we've got 100 that were observed without the flu. And our expected value there, I believe, was 94.73. for the next entry there, we had 110 that were observed. And then our expected value was 110.52. And then for the last entry there, we observed 90. And the expected value was 94.73. Okay, so when we sum all these up, that'll give us the chi-squared value for our test for independence. Okay, so let's move on to the next slide though, and here we can use the calculator to perform the test for us. So let's have our calculator compute the p-value for us using the chi-squared test. So before we do that, we're going to go ahead and enter all these values here into a matrix. In this case, it'll be a 2 by 3 matrix. You've got 2 rows, 3 columns. Okay, so we can go to matrix. So on your calculator, you'll go to second matrix and then edit. Okay. And then from there you can choose what matrix. We're going to enter the values here into matrix A. And then once we do that, then we can go to stats, tests, and then bring up the chi-squared test. For the input value, for the observed, it'll ask for 2 things. It'll ask for observed and expected. For observed, we'll select the matrix that we entered these values into. And then for expected, you can enter any other matrix. And what it'll do is it'll store the expected values in that other matrix. Okay, so when we perform this test, I get a chi-squared value of about 2.526, and the p-value I get is around 0.2828. So we can imagine what that corresponds to here is the area of this region to the right of 2.526 on our chi-squared graph. And so with that particular p-value, notice that we were using a significance level of 0.01, so this is a little bit bigger than that. So that means that we're going to fail to reject so what is the conclusion that we can draw? In this case, because we're failing to reject the null hypothesis, we can't say that the variables are dependent. So we'll say that there's not enough evidence to support the claim that the choice of pill is dependent with the frequency of getting the flu. And in other words, we can't say for certain here that choosing pill 1 or pill 2 or a placebo has any effect on whether or not we get the flu.